We're going to talk about containers. We're going to talk about our container, the history of our containers, how to think about them, some things that we've learned, as well as some neat things about containers, or some options and opportunities for the future. So, for those of you that don't know, let me just get to these things. Containers are lightweight compute units that are more easily deployable than virtual machines, specifically because they know the operating system that they're going to be deployed onto. These things deploy much quicker. You can deploy these in seconds or minutes, as opposed to setup time of, many minutes or hours for traditional virtual machines. Most customers are asking about containers, as maybe not with the same level of intensity as AI, but it's where infrastructure is going. One of those is that it's more easily scalable, horizontally scalable, and that it's easy because you have to configure these things. It's easy to recycle these things as you need to tear them down and replace them based on your particular sort of DevOps SLAs and requirements. Being able to have stand down or refresh a production server on a cadence is something that we're seeing more and more requests for, and this is a lot of work with virtual machines and very little work with containers today. So containers, again, scale horizontally very well to handle capacity and deploy really quickly. Those are the two big things for containers. Now, Decisions has been around for quite a while. Version 5 and below, we had no container support. Version 6, we had no, I'm just kidding, we have some container support. Josiah, right? Am I right?
Yes.
Yeah. In version 6, we released a container capability. It was beta. I don't know that we called it beta. No one used it. But we did release our beta container capability. You could run very simple flows or rules in a container. That container could scale. It could do all the things a container can do. But you couldn't use custom data types or integrations. With our release of V7, it was still simple flows or rules. You could now use custom data types and integrations. And some of the reason for this is that we had done the hard work. I say as if I did any of it. Our development team had done the hard work of swapping our application from Decisions Framework to Decisions Core. We removed IAS as a dependency, and not really related to containers, but we added the ability to run decisions on a Postgres database. We did this because of some of the cloud-based Postgres scaling databases that we wanted to make sure we supported when we started getting into high horizontally scaling use cases. And you'll see here in some of my later slides that we don't yet have a good set of experience with doing a lot of horizontal scaling container use cases. With version 8, which was released not this past February, but the February before, we now have the ability to not just run simple flows or rules, but the entirety of the decisions and user experience, dashboards, portals, studio, forms, XYZ inside of your container. So the first thing to understand is what a decisions container is and is not. So here, this is like the weakest little laser. It doesn't even show up. So on the left-hand side of the screen, we have traditional containers. Now, traditional containers are not always, but very often, very ephemeral pieces of compute. They exist for seconds or minutes or for hours, but they are spun up as work is required, and they are discarded when that work is complete. These things can spin up in seconds. Probably, I'm sure there's containers that can spin up in milliseconds. They're fast to start. They're fast to kill. And the significant piece here for us, at least for this diagram's perspective, is that they're usually really small. They have fractional CPU or memory utilization in the megabytes. They don't have whole CPUs or lots of CPUs and gigabytes of RAM. Not that they can't, but this is just not the traditional sort of like, this is not the common way to use containers. On the right-hand side, you see a decisions container implementation. I like to call them fat containers. I was waiting for the product team to yell at me after my first presentation because I don't think they've heard me call them fat containers. But they didn't seem to be too bothered by it. But with the decisions container implementation, we have what I'm calling fat containers. And the reason I'm calling them that is because while they are ephemeral in principle, in practice, they exist for long periods of time. And we'll see on a successive slide here, they also take a little bit of time to spin up. Like if you considered a spectrum, and on the left-hand side of that spectrum was ephemeral, and the right-hand spectrum of it was like static. The left-hand side, you'd have these containers on these traditional quote-unquote containers. Even so much so like in AWS, you'll see some of these things called tasks. You'll create a task, and a task is a container. And that container's job is just to do a little function of work and spin up and spin down. So you pay, fractions of a penny per sort of, per minute or whatever it is. They're very cheap. But that's not, you don't think of decisions as a task. On the left-hand side of this spectrum, I'm sort of asking you to hypothesize along, or sort of to view in your mind's eye with me here, is tasks or simple containers on the left. On the far right would be Windows virtual machines. And somewhere in the middle would be our current decisions container implementation. It's the full application squeezed into a container. That's not part of the application. It's not the rule engine or the form engine. It's the whole application. It's the end user studio and the runtime slammed together, just as if it's a normal Windows virtual machine. Yes, it can scale horizontally, theoretically, infinitely, but it's not like, it doesn't scale parts of itself based on the amount of work that it's doing. It scales its whole self whenever it needs to, right? So one thing in the previous session we talked about is how does decisions scale itself? Decisions doesn't scale itself. It's a container. It gets a request to launch new containers from an orchestration service that is different than itself. We are not our container implementation is not a container orchestration implementation. It's the ability to run the application in its current form in a container and let a container orchestration service like Kubernetes or some other like OpenShift or some of these other sort of orchestration frameworks to say, hey, I need to create a new container or a new container or a new container. And what you get when you spin those things up is you get a new decisions container. It's effectively a virtual machine, right? Think about it like a virtual machine. It's not like a little piece of work. It is, the volume of work is now sufficient. I'm gonna add an entirely new decisions node in my current cluster. It's just that node is gonna be a container. It's not gonna be a Windows virtual machine. It's important to keep the right viewpoint into what this thing is and is not, because it's different than what you might think than what many people have thought of when we started talking about containers and what we wanted to do. Many people have thought about this as a distributed architecture. Well, parts of the application grow and shrink, related to how many rules or how much UI is running. It's not. It's the whole application. And you can see here, like average time to start, 4 to 5 minutes. Container starts immediately. The container comes online. But because it's still this sort of monolithic piece, this monolithic architecture, it still has to do all of the setup work that we have historically done with Windows virtual machines. Like we don't preload anything onto the image. So a new container starts, and we start doing our database checks. We start unpacking all of the flows and the forms and the dashboards and all of your design stuff, your data structures. We start loading that stuff into memory. We do less compilation, we do X, we do Y, we do Z. We do a lot of stuff on startup. So while the container may say it's running immediately, for the whole portal to become online, which is what we should really view the actual sort of availability as, takes minutes, many minutes, a handful of minutes. And in fact, that time is linear based on the complexity of the project or projects that you're building, right? The more projects you have, the more complex those projects are, the longer the startup time takes. This is not something unique to containers. This has existed in our application forever. We do all of that loading on start, and so the amount of time it takes to start is a function of the amount of stuff that you have to load. Average memory required, no different than a standard Decisions virtual machine. It takes a couple gigabytes for us to unpack all of the default stuff into memory. So if you were to just compare, like, you know, a half a CPU and 64 megabytes of RAM to 2 cores and 8 gigabytes of RAM, like those are different. Those are quantitatively different, but they're kind of qualitatively different too. I already said that it's monolithic. The Studio and the end user portal are still combined. Workflows run in the container. One thing people think, and this is no different than today. Like when I launch, let's say I run a flow that ingests an Excel file with 1 million rows. That 1 million row process stays on that node. It doesn't transfer its work across to other nodes in the cluster. People think that it does. It doesn't. It's never done that. And just because we're running in a container doesn't mean it now does that. That's something we want to do, but if we're just talking about what it does today, it does not do that. And so just as it is with virtual machines, any cross-cluster workload has to be managed by a third-party technology. A load balancer, some sort of message queue are the two primary ways where you coordinate the work of a Decisions cluster, be it virtual machines or containers. Like we often internally think of load balancers as like high availability functions, but they are actually like they are that, but they're also a work coordination function. Requests come in, they resolve down to a node, and then the load balancer says like I'm going to go here, I'm going to go there, I'll go here, I'll go there on some way. And so the load balancer is coordinating the work of the cluster. Maybe not intelligently, but it is coordinating it. The cluster itself does not coordinate its own work. It doesn't, a decision server doesn't sort of raise a flag and say, I'm overburdened. I need to pass this work off to my friend. They are discrete units of work, discrete compute units that are doing the work that they've been given discretely. Really clarified that one. Some things we've learned, not a lot of uptake in people needing to host on containers. Right now in our world, 70% of our customers self-host. And of those 70%, less than 5% are hosting in containers today, right? So we've had a roadmap goal. We've had the roadmap we have had has been to get to containers. Everything we've done in the last few years is not exclusively, but it has been specifically to get into the ability to run a container. And now that we have it, even new customers are not running in containers necessarily. So I think there's a lot of ask for it, but not necessarily a requirement for it. So we've seen that be a bit slower than we expected. We really do well with container setup work when the team on the other end has got a strong container management practice, right? We are still learning. This is new for us. And getting and understanding what to do, how to deal with containers, ensuring we've got all of the configs ahead of time, identifying parts of the product and then fixing the parts of the products that don't handle container sort of configurations or architectures well, has been an ongoing thing for us. So right now, given the maturity level of us as an organization, we really need a strong container, a team on the other end of the line who has dealt with containers a lot. And then these last 2 points are more about my reasoning for why that 5% is why that 5% slice is so small. One of the things is, at least in the current use cases we have today, the variability itself of the load is very invariable. That was a dumb way to say that. Like we see load vary, but it's not like minute to minute. Like the load is not spiking in sort of very random ways with the use cases we have. We see batch use cases where at night or on a weekend or at the end of the month the load changes, and that's a place where our current container implementation I think handles really well. Those things spin up, they can do work, they can spin down. It's not fit for like a place where any given minute of any given hour, your throughput might increase by like 10,000%, right? Because of the length of time that it takes for a container to fully come online, these things aren't going to be as burstable as some people might think. So what I think is happening is that we don't actually have high variable use cases today. We have lots of high volume use cases, but that volume is fairly static, or it is restricted to certain points of time. It doesn't occur randomly throughout the day, right? It seems to be at certain, sort of like at the end of the week, during the evening, end of the month. It's actually at defined times. And right now, containers are really a preference and not a requirement. We have some people who are using containers. We are in conversations with people about how to set up containers and use them. But it is really, at least in the customer base we have today, more of a preference than it is a requirement of their particular use case. And I think part of that too is just how fast, how efficient at handling work a decision server is. It's like two things, right? Like it's really fast at handling work, and it kind of has a big default resource footprint. So to run it, you kind of already have a lot of resources allocated, and it is fast, so you can do a lot of work on it. And so it'd be one thing if it was very small, and then it could grow, right? But it was slow, it's very fast, and it's also big, and so that default footprint can handle a lot of work already, and so it doesn't really need to move around a lot. And move around probably would mean, in that example, like add additional nodes. The one thing that it gives you, though, is it's a lot cheaper. So what you see here is the cost it takes from Azure for an 8-core, 16 GB RAM VM to host a decisions instance. On the top line, you could run a decisions container for Azure cost at $292. If you run that as a standard Windows VM, it's $438. And the only difference there is that you don't pay for a Windows license if you run a container. And the Windows license can be significant. We have a customer of ours who has like 3 16-core clusters throughout the world to ingest heartbeat data from devices and process rules against that heartbeat data. And I believe their annual cost just for the decisions hosting is $160,000 to $180,000. When we cost that out for containers, it drops to somewhere around $100,000. It was like $65,000 to $70,000 cheaper by just not having Windows licenses, not changing the number of cores, but just not having to pay Microsoft for a Windows license. So there are cost savings here associated with container-based hosting that on a long enough timeline, like this is one server, so you'd have many servers, right? And so you can imagine how that cost savings amortized over time could be quite substantial. So if containers, if our base resource footprint is high, if the container is efficient, if the container doesn't spin up in seconds but in minutes, like where are good use cases? We just said, if we have batch processes that occur at certain moments in time, that's a great time. It's not that we have to know ahead of time when the batch runs, but it's that it happens at a certain time. And so as it's happening, as the batch is kicking off, right? Imagine that every week on Sunday, we fill up a queue full of millions and millions of records. Well, as those nodes start processing that work, they can start coming online in their sort of few-minute time frame, adding more workers, pulling work, adding more workers, pulling work, and then as slowly as they've been added, they can be quickly shut off once that work is done. But it also lets us play around with a multi-tenancy model more, and we don't have anyone doing this. This is kind of sort of ideation is people that are much fancier than me would say. But what it could do is allow us to isolate business critical applications from the other processes on the application server. So while you currently deploy projects into decisions, there are things that are application level for projects, like you have code compilation. So when you deploy a project, you get a code compile. Code is managed at the application, not the project level. If you were listening to Heath's roadmap, you'll understand that some of the near-term major roadmap goals are to ensure that some of those application level components or services are moved to the project level. But right now, not without having project view or deployment server in hand, you can break a project by deploying a different project into production, right? You can cause because code compile occurs at the application level. And so, and that might not be acceptable for a project to affect another project. So one thing is, from a multi-tenant hosting perspective, we might be able to sandbox business critical applications better than we can today. What you can imagine here is like this Linux host, right? Running 3 different applications. One where we dump everything, and then 2 other specific business critical applications, all on the same host, right? And then all scaling independently of one another, right? So we might be able to say business critical app 1 needs to scale independently of critical app 2. Now, with outside of decisions, like we were saying a moment ago, all of the orchestration and all of the management work happens in container management services like Kubernetes. And so we don't set that, we don't confirm that, we don't enforce that. But what could happen is you could have multiple hosts now spin up so that you can have multiple critical app 1s running as its workload increases, while you're just leaving, generic, what that's supposed to say is generic apps and rules, just sitting around sort of doing whatever it's doing. So the idea here is like sandboxing. Why do you leverage? Your workload variability is counted in hours or days, not in minutes. It's really, like I said before, it's very easy to recycle these things. Ensuring that you can tear down and then respawn a production server is something that we hear more and more of in the support channel. And historically, we've had people just jump through ridiculous hoops to try to get a decisions virtual machine to be able to spin up programmatically with scripting. That's very, very easy with containers. With the config files and all the other files that you have to set up for it to work in the first place because it wants to spawn itself multiple times, that makes refreshing and recycling a PowerShell or command line activity, not something that is bespoke or specific to decisions. We've done a lot of work to make that a lot easier as we've moved to a place where the whole app can run in a container. And then it simplifies some DR scenarios because it can already deploy itself, because it's deployable. Like having it run in a DR scenario, you've already got a lot of that DR work set up for you automatically. And then last here is just a little bit of talking about our training server architecture. So if you've used our training server since September, you've been running a decisions container. So on try.decisions.com, what we have are multiple Linux nodes behind a load balancer that all share a SQL server. And on those nodes, we're running a variable number of containers to serve up the studio experience that the trainees are using to build flows and forms and all the other things and all the projects that they build in training. And so we have you on one of 10, we deploy a container for you on one of 10 Linux nodes, and you don't know what node you're on. And you're not actually in the same space as another trainee. You can't inadvertently affect what another trainee is doing, right? I mean, there is a shared database, so theoretically, you could do something terrible to the database and overuse its resources. But in terms of deleting someone's work or making a change to a project that's problematic, that can't happen. So one of the other things here, we've kind of talked about this sort of multi-tenancy sandboxing idea, is shared development environments. Today, with Decisions, you license a development environment. Everyone edits in the same environment. Now we use permissioning and folder structures and other things so that Josiah's work and my work can't be used. But for one thing, that requires us to set up all that permission structure. And it's not trivial to do that, right? And Josiah can inadvertently break my stuff, right? Probably out of spite, right? Maybe not. But with something like this is, and I'm not saying this is part of our roadmap. I am just theory crafting or whatever about sort of more things. Like I said, this is titled Things We've Learned. I'm just thinking of new options for us from a product management standpoint. But we might be able to do shared development environments that are distinct from one another, but centrally located on a server, as opposed to saying, like, if you want to have separate development environments, you have to install decisions on your local, which is what our answer today would be if you said, hey, I want to be able to work independently of anyone else. And with that, I'll open the floor for questions. How long did that take me? I was late, so. Oh, look at that, 30 minutes. Any questions?
Is there any work being done to increase the time for unpacking the container? Right now, we're having to do all the database initialization stuff to let them know, like, hey, we've already got this initialized for the instances of the container that are up already. We don't need to do it again.
Some, I don't think it's a significant focus right now, because I think they want to get clear on if they should optimize what we have now or just sort of trudge down the path of the more microservice architecture. Will we probably make tactical changes to fix things? Yes, but I haven't heard anyone talk about let's put together a squad to say, like, let's get this down as low as possible. Yeah.
Does each container require a separate license key for those that auto-apply when they're installing?
Yeah, you use self-service licensing for it. So you have to specify the keys in the environment file so that it connects to the online license server to license itself. So yes, but you don't actually apply a license like you do to a virtual machine. Because one of the tricky things about a container is you don't interact with its file system directly because it disappears and reappears whenever it starts up. So, like, you have to prep things or have the environment files and these config pieces already in place so that when it spawns itself, it has all that stuff automatically. So where with a virtual machine, we would go run the utility, get the thing, we'd put it back and restart. Restarting is more of actually is closer to deleting the virtual machine and recreating it than it is turning a service on and off. And so you do have to have a license key for it. There are restrictions on it, but it's not you don't actually interact with a manual file in the same way. Please? I've been waiting for this day my whole life. No pressure. If I had to guess, I don't know, you tell me, salesperson. I think these are capability questions on RFPs and things like that. Like, technology teams will ask questions like, can you run in a container? Like, they're like future-proof type questions from the IT teams that are qualifying or approving a particular purchase by one of our customers. The customer themselves probably doesn't care how it's hosted. They may care how much it costs, but they don't actually care how it's hosted. But their team might say, we only, like, I'm a customer, I'm gonna buy this thing, right? And we only host in containers. So you can't buy a software that we host that can't be hosted as a container, right? Now, if that's like a hard policy or just a preference, it's hard to determine. But when sales gets these types of requests, we want to make sure that we can check boxes on these things.
Yeah, I would say most of what I've seen, exactly to your point earlier, is a preference for those requests that their IT department is running things in containers. It's not necessarily like a separate requirement that their environment is running in container, but they also they want to make sure all of their from what I've seen, there hasn't been a hard requirement of why they need to be back on containers. I don't know if that's a question. Either way, I think we're in for
Tim? I'm just kidding. You don't have to ask a question just because I called your name.
How does the scalability work for them, given that you're still listing like calls and whatnot? Is it like a baseline level, or does it go below that?
That's a Kubernetes question, right? So, like, you set it to say if a certain amount of memory, a certain number of requests, a certain number of CPU utilizations. They have all sorts of algorithms that they use to figure out if they should add a new compute unit to the pod or whatever. It's not, but decisions just sits around consuming requests, right? And then like a system says, create a new one of you. And then it spins itself up. It doesn't determine how to spin itself up, right? It doesn't know it's supposed to spin itself up to that point about like a node can do a lot of work. So like you could have two nodes, right? And a request could come in and it could just crush one of those nodes, right? And theoretically that cluster doesn't scale because the other node is just sitting around waiting for more requests because it's got threshold, it's got overhead, right? Because it's not distributing its work in any way. It's not like when you run like a run flow for list step, it doesn't say like spawn me 1,000 containers to run this work, right? It doesn't do that. Like when it's more of like, hey, it's the end of the month and everyone's logging in to submit their expense reports. And the traffic has increased and it's gonna be like, all right, we're at X% CPU on all our nodes, add a new one, and then check again and add a new one till that CPU utilization gets below that configuration. But that configuration is not a decisions thing. It's in the orchestration software that is managing containers. They just happen to be decisions containers. Please? He's like nodding in the affirmative. The magic of something. Movie magic.
For the 5% of people who are using containers,
Yeah.
are we managing that, or is that
Nope.
on their?
They are managing it.
Okay, so that could be another reason why they go with containers versus management. Do they have the resources to manage?
Could be. But like, yeah, so but like they shouldn't, wouldn't, or couldn't, whichever way you want to come down on that, pick how we host for them, right? Like eventually I'm sure everything we host will be in containers, right? That's coming, we just don't know exactly when that date will be. But they shouldn't even know that. It's more of like, right, it's like, hey, this is how we host. So it's more of this is one of those places where there's that contention between, are we an on-prem or a SaaS solution, right? And so containers are more about, or like have this sort of on-prem sort of, what baggage or whatever. Like how does that customer need to host for them to get the approval to move forward on the purchase, right?
People notice a little bit, because the file path changes.
You're talking about like if they're in a flow, like using file steps?
Yeah, because there's some
Sure.
people who manipulate a lot of files, and they won't notice because the slash is suddenly.
That's fair. Yeah, there are moments, there are times where you might have to use a different syntax, right? Because Linux file system is different than Windows. So that's true. Conrad? No, I'm just kidding. You've just been blown away. The best presentation you've ever seen. Flew across the Atlantic for this one. So worth it. Yeah, so worth it. What's that? Why do we have to give it out? I just won it. All right. Any questions that you might have, ma'am? Anything I can answer for you? Yeah. Oh, please.
So if I, for example, we develop an app that is running a scheduled job every couple of days and is doing heavy database work and stuff.
Yeah. Okay.
Run the task and then kill the container.
Okay, sure.
Do we set up a scheduled job to say, hey, start this container, blah, 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 or
right.
Do we set up the scheduled job on the container that we're creating, and then when that container starts, run the job, and then once the job is complete, kill the container.
Yeah, so that's the thing, like it's not sending work to itself. So you can't say start a scheduled job on a container, right? Like it doesn't have the ability to move work. In a cluster, you got a job server. All the scheduled jobs run on the job server, right? Which means one of your container nodes, just like in a virtual machine cluster, is the job server, right? You could contrive a way to run a job like on a decision server that itself is sort of like scalable, but what you would actually be doing is like building a scheduled job that runs an API call that calls into a separate decision server to fire off a process. You can't say like, send this work to that container, right? You could do it, it's technically possible, but then you would just be interacting with that other decision server as if it's a web server of some kind that just happens to be decisions that you can shoot work to, right? I'm not sure if that makes any sense. But no, you cannot say like, hey, this is a long-running scheduled job. I want to spin up a new container and run it on that. You can't do that, right? What could happen is you have two containers and then the scheduled job peaks the CPU on one, and then now all of the traffic, the load balancer is making all the traffic go to the other one, and it peaks the CPU on that, and then you get a new one, and a new one, and a new one, at which point when everything settles down, those sort of disappear. That would happen, but it's not, it's more about generic activity than it is specifying a particular piece of functionality to run somewhere specifically. You don't have that level of control today. Anybody else?